3/4 divided by 5/8. So I'm going to draw 3/4. And I'm going to divide that into, okay, so there's 3/4. I want to see how many 8s are. Right now I don't have 8 pieces. I only have 4s, okay? I can't divide that into 8s until I know what I'm looking at, all right? So I'm going to show the common multiple step here, how this actually works. So in order to make 4s turn into 8s, you would multiply by 2, right? And that would make the 3 turn into 6. So basically I'm going to multiply by 2. Now I have 8s. So now instead of 3/4, I have 1, 2, 3, 4, 5, 6 8s. 3 times 2 is 6, 8. So I'm dividing the 6 into just groups of 5. Now I want you to think about that. I'm dividing 6 of these into how many groups of 5 can I get into them? Well, here's one group. Okay, there's one. Or if it helps, you can count 1, 2, 3, 4, 5. Okay, there's one group of 5. And then I have this one piece left over. Out of another whole would be 5. So this is one piece out of 5 to make a whole. So what I have is I have one whole. Okay? I got one whole group of 5. And then I had 1/5 left over. So I have 1 and 1/5 of a group. Okay? So, or I could see it as I have 6. Or this could also be equal to 1, 2, 3, 4, 5, 6. It could also be equal to 6/5, which is the same answer. Okay? There's no difference there between those. So hopefully that makes sense. So in this case, I was dividing a larger number. 3/4 is bigger than 5/8 because 3/4 is 3/4. It's more than a half. 5/8 is just barely over a half, and this is one more than a half because 2/4 would be a half. Just to talk about equivalency here, 2/4 is a half, right? So 3/4 is one more than a half. 4/8 is half. One more would be 5/8. But these are smaller pieces, so this is smaller. So this answer still ends up being bigger than 1 because we're dividing by something smaller. Now the last case I'm going to do is when you divide by something that's bigger than the fraction you're dividing into. And that's when it gets a little hard because you've got to actually think about what it would be if it was, you have to draw out like a ghost picture of what you don't actually see. So I'll do that next. Now I'm going to do an example of dividing by a number that's bigger than the original fraction, which is a little weird, but if you follow me, I think it'll make sense. You have 3/8, which is this much, and I'm going to draw all the 8s and then just dot out where the 3 are because it's kind of important that you, whoops, that's not 8s. Hold on, try that again. So we have, there's 4, 2, there we go. Okay, and I need 1 1/2. Okay, well anyway, we'll go ahead and do this. So let's shade in what 3/8 looks like. This is 3/8. There's 1, 2, 3 out of the 8. So I'm going to dot everything else, or just dash it. Because these are all, this is like a ghost image. It's not really, because when you do division, you're only dividing out of what you have. But you kind of need to know how much you're missing, because in this case you're dividing by a larger number, so you're dividing by something larger, so you kind of, basically what you're looking for is how much are you missing. So there's a full 8. This is 8/8, okay? So that's a whole, that's your 1, all right? And then a half is going to be 4/8, so it's just going to be half of that. There's 4/8, and again, this isn't shaded because this is just looking at what 1 1/2 would look like, so I can see how much I actually had. 1 1/2, the answer would be whole. Would be 1. If you were dividing 1 1/2 by 1 1/2, you would end up with 1. But you don't have 1 1/2, you have much less, you're going to end up with a much smaller number. Okay, so this is 8/8, this is 4/8, this is 1 1/2, okay? So the question is, how much do I have out of 1 1/2? Or if I divided 1 1/2 into this, how much would I actually have? Well, you have 3 of these out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So you have 3 out of what should be 12 total square rectangles for your whole. So this is a number much smaller than 1 because you're dividing something that's bigger by something that's larger than the number you started with. So 3 out of 12 is what you actually have, which it should be smaller because you're dividing by a bigger number, so the actual amount you have when you divide it out should be smaller. Okay, and that makes sense. If you think of whole numbers, like if you if you took 6 and divided by, wait, I did that backwards. If you took 2 and divided by 6, what you've got is you've got 2 and you're trying to, distribute it among 6. Let's say you have 2 candy bars among 6 people. Well, each of them is going to end up with just a third of a candy bar, or a third of a piece of pizza, or something like that. So each person is only going to end up with a third, and that's, so they're not going to end up with a whole. So the question is, out of all 6, how many will each person, well, they're just going to get a part. So if, out of all 1.5, how much is 3/8? It's going to be just this much out of all of it, which is 3/12, which simplifies to 1/4, right? Okay, so let's do the division algorithm on this and see if we get the same answer. So hopefully that made sense. When you divide 2 by 6, you're going to get a much smaller number than 1. The question is, what's the smaller number? Okay, so the division algorithm is 3/8. First you turn this into 2 times 1 is, one set of 2 over 2 is 2, plus 1 is 3 over 2, which gives you 3/8 times 2/3. Okay? When you multiply again, now you're multiplying, so you go straight across. That gives you 6 over 24, which reduces to 1/4. So I get the same answer. Now again, remember, I don't care what the whole is. The fact that these are 8s is irrelevant. When you do division, you don't care about the whole. You're just taking the number of pieces out of what you actually have that you're looking for, what's shaded. You're not looking for the sizes out of the whole, whereas in multiplication you do. Okay, this should give you a few examples, so hopefully this will help you with the homework.